And now whatever we have discussed yesterday, today I will give you as a definition form. So if you want to write, it's up to you. Otherwise, the PDF will be sent to you as well as a recording.
Okay.
Just listen the class, and wherever you find a difficulty, you can immediately ask me. We have only one-to-one interaction, no other student. So you have to ask the doubts, whatever you. Matrices, we start. First of all, actual definitions. Actual definition of matrix. Rectangular or square arrangements of real or complex numbers. Real or complex numbers. E is called so whatever we said, that we have to write as an example. So you see, in mathematics, anything if you want to define, you have to define with the help of example. If example is not given, it means that is incomplete. Okay, definition with example. Okay.
Okay, sir.
Let us give some examples. It's not compulsory to give the name always A. For my convenience, I'm taking this one as equal to A. Like we have did yesterday, so many examples. Still, I want to continue. -1, 0, 3, 4. Okay. So this is an example of a matrix. What we said? Rectangular arrangement or a square arrangement. How many rows are there? We did yesterday the concept of the rows. You see, I said already this is called a row. Yes, 2 rows. And how many columns?
2 columns.
Very good. So order of this matrix is 2 by 2. Correct?
2 by 2.
Another example. Another example is 1, -1, 2, 3, 0, 4. What is the order of this matrix?
3 rows. 3
Rows.
columns.
How many rows are there? How many rows are there?
2.
2 rows. Very good. Yesterday's homework you did it. Means you did the homework. 2 by 3. So that's correct. So there are so many examples. You can see if rows and columns are equal, such matrix is called a square matrix. That individual definition also I will give you. And rows and columns are not equal is called the example of rectangular matrix. So what do you say, rectangular or square arrangement? So we have taken a set of numbers. Real numbers means it's a positive numbers. Complex numbers means it may be negative numbers. So it is a collection of real or complex numbers. So this is the definition of matrix. I hope you understand.
Yes, sir.
Now, types of matrix. First one is square matrix. So very, very simple definition of square matrix will be, what is the definition? A matrix in which rows and columns are equal. Rows and columns are equal. Rows and columns are equal. Rows and columns are equal called is called, what do you call it as? Square matrix.
Square matrix.
SQARE, square matrix, where rows and columns are equal. We have a lot of examples to give. Still, let us take, this is the best example. Suppose represented with A. Simple example, 1, -1, 2, 3, 4, 5, 0, 0, 1. What is the order? Don't forget to write the order. What is the order?
3 by 3.
Yes, 3 rows, 3 columns. So rows and columns are equal. According to the definition, what we said, a matrix in which rows and columns are, we use this word.
Equal is called square matrix.
Is called a square matrix. So first definition, square matrix is over. Now second definition, rectangular matrix. Rectangular matrix. क्या होना चाहिए definition बोलिए आप? Can you tell me what definition is possible?
A matrix in which rows and columns are not equal.
Excellent, excellent. Very good answer. Okay, so a matrix in which rows and columns are not equal. You have finished this topic already in your college?
No, yes, sir. We are in trigonometry right now.
Okay. So you have the idea about it. Do you have an idea about this one?
No, sir.
Again, the example. I want the example from your side again. Can you tell me the example? Is it the example is written here in your screen? Any example you can say, the rectangular example. Which one is that?
1 - 1, 2.
Very good. 1, -1, 2, 3, 0, 4. Because the order is 2 rows are there and 3 columns are there. So then it is called a rectangular matrix. We can take one more example also. 1, -1, 2, -2, 1, 0. Now again, how many rows are there? There are 3 rows and 2 columns. In this case also we can say that rows and columns are not equal. Understood?
Not equal.
So such matrix is called rectangular matrix. Okay?
Matrix. Okay.
Now next definition we can discuss, that is called identity matrix. It's a important identity matrix. Identity matrix. So what is that? A matrix in which the elements of diagonals, is same और bracket में लिखेंगे, that is 1. And rest of all elements. Rest of all elements are zeros. Is called identity or unit matrix. Unit matrix, comma, denoted by, here there is a special thing we are adding there, denoted by capital I. Now look at one small question is arises. What do you mean by diagonal? This question will arise. Now see what's that? Denoted by I, so we start with I only. Now you see what is the meaning of diagonal. First row of the first element is 1 and second row of the second element is 1. Third row of the third element is 1. This is called the diagonal. Rest of all the elements are 0. 1 0 0 0 1 0 0 0 1. डायगोनल कभी भी फर्स्ट एलिमेंट से लास्ट एलिमेंट तक रहता है, रिवर्स ऑर्डर में नहीं. ओके, फर्स्ट एलिमेंट ऑफ द फर्स्ट रो टू द लास्ट एलिमेंट ऑफ द लास्ट रो is called the diagonal, and this is the order is 3 rows and 3 columns. Similarly, we have a identity matrix example in 2 by 2 also, that is 1 0 0. So if you see here, the order is what? 2 rows and 2 columns. This is the only example. For here for rectangular matrix, you can give any elements as an example. Square matrix, you can give any examples. But here there is a restrictions. What is the restriction? The elements of diagonal should be 1 and only 1. No other element is possible. 1 and rest of the elements is compulsory 0. Okay? That type of matrix is called identity matrix. It is an important example. Important definition also we can see. Now moving to the next definition I will be taking now. Now look at. Next is called scalar matrix. SCALAR. Somebody they may call it as scalar also or a scalar also. Pronunciation is no problem at all. But you should know the definition. You should know the meaning of this. What is the definition? A matrix in which the elements of diagonal is same. We should write here, mention करेंगे एक चीज. We have to mention that except 0 and 1. It is a restriction. It should not be 1 and it should not be 0. And rest of all elements are 0 is called scalar matrix. Definition is there. Can you tell me the example? Once if you understand the definition, then only you can give the example.
Let me read it first to myself.
Denoted by A, for example. What do you say? Matrix in which the elements of diagonals is same. It should not be 1. It should not be 0. 0 नहीं हो सकता elements of diagonal. 1 भी नहीं हो सकता. So other than 0 and 1 क्या हो सकता बोलिए? For example, pi हो सकता. 0 0 0,
Any number.
5, any number except 0 and 1. If it is 0 now, it is become 0 or null matrix example. All the elements become 0. If you take 1, it is becomes the example of identity matrix. So we do not take 0, we do not take 1. Except 0 and 1, you can take 3, 3, 3. You can take 4, 4, 4. You can take -1, -1, -1. So the elements of diagonal should be same. Okay. This is the definition.
Okay.
Now next, moving to the next definition. Trace of a matrix. Trace of a matrix. What is the definition? The sum of the
Sir, 5 and 0, Leonora.
yes
5, 0.
5, 0.
Example, as an example, you have taken 5 and 0. So, 0.
5, 0, 0, 0, 5, 0, 0, 0, 5. Not compulsory to take 5. You can take anything. You can take as like this also. -3, 0, 0, 0, -3, 0, 0, 0, -3. जो भी एलिमेंट्स डायगोनल में आ रहे हैं वो सेम होना बस.
Okay. 0 is compulsory.
Yeah, 0. Rest of the elements are 0. I wrote here now, you see. Rest of all elements are 0. Okay, na? Next. Trace of a matrix. The sum of elements of diagonal. The sum of the elements of diagonal is called trace of a matrix. Example आप दीजिए. Now you can give me the example. Tell me any matrix. I will show you how to find out its trace. You just give me one 3 by 3 example. 3 rows, 3 column example. अच्छा एक और चीज यहाँ पे स्केलर मैट्रिक्स का एग्जांपल. It should be 3 by 3 only. It should not be 2 by 2. Okay. It should be a square matrix only. The rectangular matrix is not the example of scalar matrix. Okay. Now you take any element. Tell me the elements. Anything.
9, 4, 6.
Okay. 6. Okay. Next. Come on, fast.
5, -1,
Yes.
-3.
Next.
0,
Yes.
1, 3.
Now see how to find out the trace. Trace of this matrix. Trace of A is equal to. How to find out? You have to take according to the definition sum of the elements of diagonal. Diagonal में कितने elements है? You can see this is called the diagonal. This is called the diagonal. Now we have to take the sum of this. 9 plus -1 plus 3. This is equal to 9 plus into minus is -1 plus 3. This is 9. 9 plus 3 is 12. 12 minus 1. Answer is 11. So like that we can find out the trace of the matrix. We have to take the sum of the elements of the diagonal. Okay.
Okay.
Next definition is column matrix. Column. A matrix in which in which there exist only one column is called
Only one column.
yes is called column. So what we are going to say, there exists only one column. Rows कितने हो सकते हैं? कितने भी हो सकते हैं. 1000 rows हो सकते हैं. कितने भी हो सकते हैं. कितने भी हो सकते हैं. Column एक ही होना है. 1, 2, 3, 4. What's the order of this matrix? Tell me. How many rows are there?
4.
4 rows. But how many columns are there? Only one column.
1.
Okay. So there may be 1000 rows possible, but it should have only one column. And we can take this example also. A is equal to 1 only. What is the order of this matrix?
1.
One row, one column. Don't say 1 into 1. One by one. One by one we can read.
1 by 1.
Okay. So now you see, अपने रो कितने हैं? That is not important. Column एक है ना, बस काफी है. Enough.
Okay.
There exists only one column. That's enough. Now moving to the row matrix. Row matrix. Matrix in which there exists only one row is called row matrix. Once again, examples are so many examples. Let us take A is equal to 1 minus 1 2 3. So what is the order of this matrix?
4 rows, 1
One row,
column.
4 column. One row, 4 column.
One row,
First of all, rows should be there now. And now the above example again. 5 only. Again, 1 row, 1 column. It has only 1 row. Column कितने हैं? That is not important. Row एक ही होना है. So this is a row column matrix example also. Row and column matrix. And zero or null matrix example definition I am not giving. A matrix in which every element is 0 is called zero or null matrix. So for that matrix, I am not giving any simplification, and you can denote it with 0 also for origin. And this is also the example of singleton matrix. Singleton, a matrix in which only one element is called singleton matrix. Zero or null matrix example also. I don't want to mention here. You want zero or null matrix example for definition?
Yes, sir.
Okay, let me write. Zero or null matrix. Very simple definition. A matrix in which all the elements are zeros, or is called zero or null matrix. Comma denoted by this O, capital O, and examples are this one. 0, 0, 0, 0, 0, 0, 0, 0, 0. This is order is 3 rows and 3 columns. And one more example, in 2 by 2 also we can give, in 2 by 3, any example we can, where all the elements are 0, is called 0 or null matrix. Okay. Now we discuss what is triangular matrix and what is symmetric and skew symmetric matrices in the next page. Now next, definition of upper triangular matrix. It's important. Upper triangular matrix, lower triangular matrix is very important. See definition. A matrix in which below the diagonal elements are 0, comma, is called upper triangular matrix. Now example is important, very important. Suppose this is equal to matrix A. So what we are going to say, the elements which are below the diagonal, like example, here some matrix is there. Here also some matrix is there. Star will be a positive number or a negative number. 0, star, 0, 0, star. You can see the diagonal is this one. Already we are familiar about the definition of diagonal. This is diagonal. You can see below the elements which are there. This is called the elements which are below the diagonal के नीचे वाले पूरे elements 0 होना चाहिए. So such matrix is called upper triangular matrix. 1, 2, minus 1, 0, 0, 0, 3, 4, 4.
It is important कि zero
Very,
ही रहना.
very important. The elements of diagonal should be 0 only. A matrix which satisfying this condition is called upper triangular matrix. Okay, quite opposite definition is lower triangular matrix, a matrix in which above the diagonal elements are 0 is called lower triangular matrix, but that should be understood. It's important. Upper triangular matrix is important because while solving the problem now, we have to reduce the matrix into upper triangular form. Upper triangular of a matrix is very, very, very important. Okay. So with this, we have to go for another definition, which is also important. Symmetric matrix. Symmetric matrix से पहले transpose का definition important. Transpose of a matrix. Transpose of a matrix. Definition. Transpose of a matrix is a matrix. Transpose of a matrix is a matrix obtained by interchanging rows and columns. Obtained by interchanging rows and columns, comma, denoted by a to the power of t. Now examples I am writing here. Example. Suppose a matrix, you give me the example of any 3 by 3 matrix, 3 rows, 3 columns matrix. Come on. Come on fast.
4, 5, 6.
Then
1, 7, 8.
Then
0, 9, 3.
suppose this is a matrix A. We are going to find out its transpose. According to the definition, we have to make it rows as a column or columns as a row. क्या करना है? Row को column बना देना है. 4, 5, 6, 1, 7, 8, 0, 9, 3. We have to make it rows or columns, or columns we can make it as a row. Columns also we can make it as a row. That is also the transpose only. Now here you see, this is a column. We have to make it as a row. 4, 1, 0. 5, 7, 9. 6, 8, 3. Getting the same answer, you see? Same answer. Right?
Yes, sir.
Such type of matrix is called transpose of a matrix, which is obtained by interchanging rows and columns. So many definitions I have given today. Okay. You have any doubt? See the previous pages. These are the definitions we have discussed today. If you want to ask anything, you can ask me, because I am going to finish the class. No doubt.
No.
So then one more class is required to finish some more definition. Okay, that will be taken in the next session, because today I have some questions to go. So because already yesterday only we have started, that's what I don't want to give you a break. So just to go through these definitions. Okay, few more definitions are also there. Then we have to go for problems, how to find out the determinant of a matrix, how to multiply any two matrix, how to add any two matrix. Okay, and there is some important definition: symmetric and skew symmetric matrices, Hermitian, skew Hermitian matrices, idempotent matrix, unitary matrix, orthogonal matrix. These are the some definitions which are left that we will be doing in the next session. Okay, I will let you know when we have a next session. Right? Let your what do you say, mommy, mommy है, auntie है,
Mommy.
जी उनको बोलिए मेरे से बात करने के लिए.
Okay.
I'll send it this recording to you. Okay. Have a nice day. Thank you. I'm going to stop.
Jazakallah khair.